Now that we have an overview of the classical toolchain, let's focus on the compilation step. A compiler takes us from high-level language source code to low-level code, usually assembly code. This is by far the most complex part of the toolchain. Other steps are relatively straightforward translations of instructions. We've already seen how it is a fairly simple process to take assembly code and convert it into machine code instructions. It's mostly a one-to-one mapping with a little bit of extra work involved in things like deciding what to do with labels. The basic compilation steps are scanning, which passes over the source code to generate a token sequence. A token is a sequence of characters separated by some delimiter. Often that delimiter is white space, but it may be other characters such as brackets or semicolons. The next step is syntactic analysis. This is where we ensure that the tokens we have are valid in the language and that they have been arranged in a way that follows the rules of the language. With semantic analysis, we need to ensure that the code actually makes sense. This includes things like ensuring that variable names are not declared more than once, or that we don't try to use operators on the wrong kind of data. During this process, a key step is to generate a parse tree. A parse tree is generated based on the rules of the language and the tokens of a particular program. The structure of the tree and its contents hold the information necessary to generate low-level code. The compiler also needs to keep track of symbols that would be used in multiple places in our code. For example, if the program includes a subroutine, its name needs to be known, and the compiler needs to keep track of the fact that it is a subroutine that can be called in other places in our program. Finally, we generate the assembly code for our program in the code generation step. Now this is just an overview, and other courses would go into much more detail. For example, there can be optimizations implemented after the parse tree has been generated that would reduce the number of assembly code instructions or limit the number of memory accesses. In this course, we're going to focus on how we identify tokens from our source code and the basics of specifying the rules of a language. The first step in the compilation process is to generate a stream of tokens. This process is handled by a scanner. A token is a meaningful sequence of characters, such as a keyword, an operator, or a constant. Identifying a keyword or a built-in operator or a delimiter is relatively simple, since the scanner just needs to do an exact pattern match with a set of keywords and symbols. For example, you could just look for the word for or while, or identify a plus as an operator, or know that a colon has specific meaning in the language. However, identifying a token that is a variable name or a constant value is more difficult, since those tokens are dynamic. In other words, they can have a variable length with variable characters. A compiler wouldn't know, for example, ahead of time exactly what numbers would appear in your particular program. So we need to be able to describe these tokens that are variable and could have all sorts of variations, but we need to be able to define them in a finite way or identify them in a finite way. This leads us to an area of computer science known as formal languages. Like many areas of computer science, this overlaps with other academic disciplines. In particular, linguistics and theoretical computer science come into play here. We will investigate 3 ways of describing valid strings in a language: deterministic finite automata, or DFAs, non-deterministic finite automata, or NFAs, and regular expressions, sometimes written as RE. Although we will be working with these concepts in the context of lexical analysis, they are actually useful tools in a variety of situations outside of the compilation process. For example, you could use DFAs or NFAs or regular expressions in areas in and outside of computer science that have nothing to do with talking about a compiler. One thing to keep in mind as we move forward is that in some ways DFAs, NFAs, and regular expressions are interchangeable, in the sense that they are used to represent the exact same set of values. In other words, if there's something that cannot be represented by a DFA, then it cannot be represented by a regular expression, and vice versa. Although it may be easier to represent something with a regular expression or a DFA in some cases, you might choose that form. Or there may be a context in which it only makes sense to use a regular expression. But ultimately, everything that can be represented by one of these forms can be represented by any of the other forms. There are standard techniques that you can study that will allow you to translate between these different forms. However, this is beyond the scope of CS 230. We will be looking at the basics of each of these tools and consider some ad hoc methods for converting from one form to another.